Algebra 1. Welcome. We are starting at lesson 40 today. Sorry, I'm moving you around there. But we want to make sure that we're understanding lesson 40. So we just finished out with the trichotomy principle. So today we're looking at exponents that we're dividing. So if I have x to the 6th and I'm dividing by x to the 4th, let's talk about that. So it's important to understand before when we did x to the 6th times x to the 4th, because our exponents are the same, we know that exponents are like a long lost friend that are one step behind. So the step before multiply is add. The step before divide is subtract. So since my bases are the same, I simply add 6 plus 4, x to the 10th. Here, because I'm dividing, the step before is subtract, it would equal x 6 minus 4. So it's x squared. Now, you can look at that visually, x times x times x over x times x times x times x, and you can actually visualize marking that out. I have 2 left, therefore it's x squared. But it's easier just to understand the concept, but you can also visualize the y. So I hope that helps you all at home. All right, so we're looking at lesson 40, and it does talk about the quotient rule, and also don't forget the negative exponents. I want to bring those up. So that's very important. Grace, can you shut the door, please? All right. So let's jump into our practice problems. So we're going to simplify on letter A. So letter A says x to the negative 6, y to the 4th, z to the 5th, over x to the negative 6, y to the 5th, z squared. Now, all right, what we want to do is we want to take a look at these and make sure that we're solving them correctly. So if I have x and x, remember that when I'm dividing, it's just subtracting negative 6 minus negative 6. So I'm just putting a minus sign between them. Y to the 4th minus 5. And then, so when I'm taking a look at these, what I'm doing is I'm just saying I have my bases the same, and the step before divide is subtract. So that's all that I'm doing, is I'm just rewriting all of these. Now, if I'm minus and minus, that means plus. Well, if I owe 6, I have 6, the x's cancel out. It's x to the 0. Then this would be y to the negative 1, and then this would be z cubed. So that is my answer. Now, your book said simplify, write the answers with all the variables in the numerators. Now, just so you all understand that typically we don't leave our answers with a negative exponent. We could flip that down and put y in the denominator, but we can't since the directions told us to leave it in the numerator. But typically standard form is we don't leave a negative exponent unless it's scientific notation. But that is letter A. Now, let's look at the distributive property. And the distributive property, we're just working more with our negative exponents. So let's take a look with that, okay? So we just did letter A. In class, we did letter B together. So right now we're looking at letter C. So letter C says z to the negative 3 over m, and it's being distributed to x to the 4th over m squared minus 3z over m. And remember, the distributive property means that all of this goes to everything inside the parentheses. So I would put x to the 4th, z to the negative 3. Then I have m times m squared would be m cubed minus 3. And then I've got z, I've got an understood 1 here, but I owe 3 here. So when I add those together, that would be negative 2 over m times m would make m squared. Now this would be the final answer. On the direction said make sure everything's in the numerator. So I need to move this up and move this up. So that would end up looking like m to the negative 3, x to the 4th, z to the negative 3, minus 3m squared, z to the negative 2. And that's my final answer because I have moved everything to the numerator just like the directions told me. All right, so great job. We've simplified, we've distributed, and we're really on the lookout for those exponent rules, remembering that as we work with those, that if I'm multiplying exponents, step behind I'm adding. If I'm dividing exponents, step behind is I'm subtracting. Now we're looking at lesson 41. So we were in lesson 40, and now we're jumping into lesson 41. So lesson 41 is all about combining like terms and two-step problems. And you've already done some of these algebraic problems. What you're actually doing is you are solving them and then using the solution to solve another expression. So that's why the book is calling it two-step. So let's jump right in, and we'll go straight to the practice problems since most of this you've done before. It says simplify by adding like terms. Write the answers with all variables in the numerator. So again, lesson 41, and we're looking at letter A. I've got x to the negative 2y plus 3y over x squared minus 5xy. Well, it did tell us to make sure everything is written in the numerator. So I'm going to go ahead and move this up. So that would give, and remember that there's no coefficient here, but it's understood 1, x negative 2y, plus 3, x negative 2y, minus 5xy. Now let's take a look at that. We moved everything, and notice that this is a like term because it's got x to the negative 2y. I've got one of them, then I've got 3 of them. So total, I have 4 x to the negative 2y. Notice the exponents stay the same. I'm just combining the coefficients. I had 1, I have 3, now I have 4. This is not a like term. I cannot combine it together. Everything's in the numerator. That is my final answer, and that's as far as I can simplify it. So great job. I hope that makes sense to you. So that's letter A. All right, we're again on page 166, and we're on lesson 41. So we did letter A. Now let's take a look at C. So C is simply asking us if I have x plus 7 equals 2, what we need to do is solve for the x. Then it says, what is the value of x plus 3? So we're solving for this x, then plugging it in to this expression. We've got a equation here, expression here. So let's solve this. Let's get x by itself, subtract 7, x equals negative 5. Therefore, if x is negative 5, plug it in over here. Negative 5 plus 3, what does that equal? It equals negative 2. So that's my final solution, and it was 2 steps because I solved this equation, then plugged it in to that expression. So that's what they're looking for there. And I'm sorry, I did not realize you couldn't see the final answer, could you? So great job. All right, so that's all that we're doing in lesson 41. Lesson 42 is solving multivariable equations. So what if I have more than one variable? How do I set that up? Basically, it's just if you're given an equation, and there are a lot of equations that we have multivariable. Distance equals rate times time, right? And what if I asked you to take that equation and solve for a different, instead of distance, what if I asked you to solve it for time? Well, it's just getting that variable by itself. So don't let it intimidate you. That's what you're solving for. So let's take a look at letter A. And again, we're in lesson 42. And we're just looking at equations with multivariables, and we're solving for an unknown. All right, so lesson 42, and we're looking at practice A. So practice A says 8y minus 13x minus 8 equals 4. Now we see there's more than one variable there. I've got a y, I've got an x, and I've got some constants. It says solve for y. I'm solving for this unknown. So I need to move everything else to the other side. Do the inverse operations. I'm going to add 13x and add 8 to both sides. That's going to cancel these two out and leave me with 8y equals 13x. And then the 4 and the 8 can combine plus 12 since they're both whole numbers, right? My goal is to get y by itself. It's being multiplied by 8, divide by 8. So y equals 13 over 8x plus, and this can reduce by 4, so it would be 3 over 2. Notice that 8 has to go into both. So that is my final answer because I've got two variables, but it asked me to solve for y. And this is super important for what we're going to be doing later in algebra. So that's why it's so important that we learn to solve these, okay? Now, the next one says solve for p. So I'm going to circle p. That's what we're solving for. It says 8p plus 3w equals w minus 15 minus 2p. So we've got variables on both sides, but it's asking us to solve for p. So let's move this p over, plus 2p plus 2p. So that gives us 10p here. But I need to move over this w to the other side. So that's going to leave me with negative 2w minus 15. All right, everybody follow what I did there? I brought over the 2p so the p's could be on the same side. I moved the w to the other side because, remember, my goal is to get p by itself. So when I subtracted 3, I already had 1. Took away 3, that left me with owing 2w. And don't forget negative 15 to bring him down. All right, now my goal is to get p by itself. So I'm going to divide through by 10. Everything gets divided through by 10. So p equals reduce negative 1/5 w minus divide through by 5, reduce. So it would be 3/2. So that is my final answer. I've got p by itself and I've solved it in terms, even though there's more than one variable. So great job. All right. So we've covered 3 lessons in a very short amount of time, but now we're jumping into lesson 43. And this might be a little bit more intimidating for some of you guys. It's least common multiple. Now, least common multiple and greatest common factor are sometimes a little bit intimidating because sometimes people try to say that least common multiple and greatest common factor are the same thing. And I want to be very quick to say, GCF does not equal LCM, okay? So that's very important for us to remember that GCF does not equal LCM. So I think that's super important to keep that straight in our minds. Now, a few weeks ago, we were covering greatest common factor. So a factor is the components. The multiples come out of the number. So if I'm saying the multiples of 10, that's 20, 30, 40, 50. The factors are what makes up 10, 2, and 5, right? So factors and multiples are totally different. When you were younger, your teacher might have you list out all the multiples, and that would take a long time. So in algebra, we actually set it up a little bit different. So remember when we were doing greatest common factor, we circled the things in common, what those factors were that they shared. Well, now that we're looking at least common multiple, I like to call it a contest. So in that contest, we list every single factor the greatest number of times that it appears in just one. We don't add them together, we don't combine them together, we just have that contest. So let's take a look at some of our practice problems, and we'll jump in and solve those together. All right, so letter A, it asks us what is our LCM of 14, 20, and 30. So we've got 3 numbers. Now we can sit and we can write out all the multiples. We go 20, 40, 60, 80, 100, and see when these two meet. But it could take a long time, couldn't it? So what's faster is just to break it apart into its factors. All right, 4 and 5, 2, 2, and 5. This would be 5 and 6, 5, 2, 3. All right, so now we've listed all of the prime factorization. I love factor trees, don't you? They're so much fun. All right, so let's start. I always start with 2 and I work my way up so I don't miss a factor. So if I'm solving for my least common multiple, I use every single factor the greatest number of times it appears in just one. Here's 1 2, 2 2s, and 1 2. What was the most amount of times that 2 was used in one factor? It was 2, wasn't it? So you can write 2 times 2, or you can even write 2 squared, whichever way you prefer. We'll show either way. All right, so I've used all my 2's. Now let's go through. No 3, no 3, 1 3. The most amount of times that 3 was used? 1 time. So I write it once. Notice I didn't add up all my 2's. I didn't go 1, 2, 3, 4 and write 2 4 times because I'm not adding them all together. That would be a multiple, but it wouldn't be the first multiple that meets. So instead, I have to use the greatest number of times it appears in one. Now, I've used 2, I've used 3. The next prime number is 5. Here's 1 5, 1 5, and no 5s. So we write 5 1 time. All right, any other factors you see? 7. 1 7, and that's it. So now I'm just going to multiply all this together. So I know that 2 squared is 4. 4 times 3 is 12. And I know that this is 35. So I need to know what 12 times 35 is. So that would be 70, hold my place value, 35, 0. So 420 is my LCM. How did I get that? I did my contest, right? I used every single factor the greatest number of times it appears in one. There were a lot of different factors, weren't there? So all of that went into my contest. I did not combine them all. That would be a multiple, but it would be a huge multiple, not the first multiple that they share. And that's what least common means, is it's the first one that they all have in common. So wouldn't it be amazing to have to sit and write all those out, 20, 40, 60, all the way to 420? Woo, I'm glad we have this process. All right, so that was letter A. Now, let's jump all the way to letter C. So we did letter A together. Let's do C. All right, again, we're still doing least common multiple, but this time we're going to add some variables to the fun, all right? And I think you'll find it just as much fun, okay? So letter C is 4a cubed b to the 4th and 6a to the 10th b squared, all right? So let's take a look at that. So 4 is just 2 times 2. 6 is 2 times 3. So I've got to use every single factor the greatest number of times it appears. Now GCF, the only thing it has in common is a 2, right? But we're not doing GCF, we're doing LCM. So the greatest number of times that 2 appears is 2. So my LCM would be 2 squared, or 2 times 2, because there were 2 of them. And then there's 1 3. So that would end up being 4 times 3 is 12. So that's my number. Now I've got to take a look at my variable. I've got a cubed or a to the 10th. Which one wins? A to the 10th. B to the 4th, b squared. Which one wins? B to the 4th. Notice I don't add them together. I'm using the greatest number of times it appears in one. So what is my least common multiple? 12, a to the 10th, b to the 4th. That is letter C. Let's do D together since C was so easy. How about 12x to the 4th, y squared, m cubed, and 20x to the 6th, y m cubed. All right, so let's do our numbers first. So this would be 4 times 3, 2, 2, and 3. And then 20 would be 4 times 5, which is 2 times 2 times 5. All right, so let's take a look at our factors first. So my LCM, there's 2 2's and 2 2's, which would make them GCFs, wouldn't they? But in my LCM case, it's still 2 squared is the most amount of times that 2 is used. I've got 1 3 and 1 5. I use every single factor the greatest number of times that it appears in one. Now I've got 4 x's or 6 x's. So I'm going to write x to the 4th. I've got y squared and y, so I'm going to write y squared. Now, m should have come before x and y because numerically it comes before, but both of them are m cubed. So let's rewrite it in the right order when we do it together. 4 times 3 is 12, 12 times 5 is 60. M should come first, then x to the fourth, y squared, because we write everything in order. And that is my least common multiple. This is letter D on lesson 43. So you guys did a great job, and I hope you enjoy this week having your contest with your least common multiple. Your greatest common factor, now please understand that this is not part of the question, but just so we keep straight what's the difference, let's find the GCF of letter D, even though that's not required, just so you can see the difference. So since there's 1 2 in common and another 2 in common, my GCF would be 2 times 2. Now, there would be a max of x to the fourth in common. There's only one y in common, and both of them share m cubed. So my GCF would be 4 m to the third y x to the fourth. So do you see the difference? GCF is what it shares. Least common multiple is the first multiple that these meet together. All right, so remember, this was not part of the practice. I just wanted to show the difference of least common multiple and greatest common factor, since that's an easy confusion. All right, thank you guys so much. I hope you have a great week. God bless.